Okay, Bismillah. Okay, folks, welcome back to our SATS class. So this is Tuesday today. We're going to be looking at 2011 Test B Science Test. Okay, let's move on to the next page. So this is what a cover page should look like. Can you please turn over to your first page, please? Okay, right. I want you to open there. To page 1. Okay, right. Excuse me a second. Here we go. Question number 1. Some children visit a butterfly park. Do you have that? Come on. Yeah? They use the pictures below to identify the butterflies they see. So we got some names here. Okay. Sally makes some notes about one butterfly she sees. Oliver tries to use Sally's notes to identify the butterfly. So this is Sally's notes here. It has feelers on its head. It has wings. Explain why Oliver cannot use Sally's notes to identify the butterfly. Hang on a second. Okay, right. So question A. Hang on 1 second. Okay, that's excellent answer given by over there. All the butterflies that we have above us have feelers on their head and they have wings. So that won't really help us to. So let's start here. Okay, right. I want to be actually here. Okay, what is going on here? Okay. So all the okay, I don't know what's really going to happen. Let's pause it. Okay. Now, Ahmed drew a butterfly. It is not a common blue. Tick one feature of Ahmed's butterfly and describe how it is different from a common blue. So we're going to choose. So, for example, if you choose body, you can tick that one. So how is this one different than a common blue? How would we describe the body? The common blue is what? The body is nice and
straight,
long. Common body is nice, long is thin. Okay. All right. And so what could we say then?
The common body, the feature of Ahmed's
because it is.
Because its body is shorter.
Yeah, that's what I say. It is not long.
I
Hang on 1 second. It is not long and thin.
I got one from the wings.
Okay, right. Give me one from the wings and go on.
Okay, because the common blue's wings are just boring and plain, whereas
well, boring and plain, that's not exactly scientific, it's boring and plain. Why can't we just say the common blue's wings have got no patterns on them, whereas Ahmed's drawing has patterns. So that could be if you use the wings tick. So we can have different options for the answers there. Well done. That's good. Okay, are we happy with that? Yes?
Yes.
We got the answers on that. Okay, right. Okay, page 2. Question C. The children write conclusions about the butterflies. Look at the butterflies inside whether each conclusion is true, false, or you cannot tell. Tick one box for each condition. So let's have a look. So all of these butterflies have spots on their wings. By looking at the pictures, do they all have spots on the wings?
Yeah. No.
No, it's false.
Yeah.
Do all have spots on the wings? No, they don't. What are you talking about?
False. The common blue doesn't.
The common blue, we just looked at that one, doesn't have any spots, it's got no pattern at all. Okay, next. All of the butterflies are eaten by the same predators.
No.
That we don't have any information, so we can't tell. All of the butterflies are the same age.
No.
Can't tell.
No.
All the butterflies have antennae which are longer than their bodies.
No, I can't tell.
That one is false. Because you can see the size of them both and they're shorter. Okay, the number of butterflies in Britain is gradually getting smaller. Tick 2 boxes to show what is likely to cause the number of butterflies to get smaller. There are fewer butterflies because there are. Okay, go on, Mr.
More houses being built on woodland or grassland.
Okay, one answer, that's enough. Thank you. Sabr. Okay? Can we not just take everything away from everybody else? More houses being built on woodland or grassland. Okay, let's have a nail. Any other reasons why we can give for this? One more reason. More schools with wildlife areas. That's not true. fewer predators eating caterpillars and butterflies. No, that's not really true either. But we have fewer diseases amongst the butterflies. We don't know that. So the only other feasible answer is fewer plants which. That's right, because the butterfly, they live on the plants. If the plants are not there, they can't live anymore. So it reduces the numbers. So it's going to be that one. Okay, spinning cardboard roll. Owen ties a weight onto some string. He winds the string around a cardboard roll. Owen lets go of the weight falls. The cardboard roll spins and the string unwinds. Owen records the time taken for the string to unwind. Draw one arrow on the picture below to show the direction of the force that makes the weight fall. Okay, any suggestions for that? So that's question 2. What we're going to do. So where is the force?
At the top, maybe. Or at the bottom.
So the force would be
At the bottom.
acting down. Right? That's the force of gravity. Question B. Take one box to show the piece of equipment Owen should use to measure the time taken for the string to unwind. Okay, not you, no. Give someone else a turn. Let's go on.
Stopwatch.
You should use a
Stopwatch.
watch. You just tick that box there. Okay, lovely. Okay, we're just going to pause there for Salah. Okay, question C, 2C. Owen repeats his test. He slots different size pieces of cardboard into the roll each time. The table below shows Owen's results. The size of a piece of cardboard, so that's a small one, medium, big, and the biggest. Time taken for the string to unwind in seconds. Okay. So as the size of the cardboard got bigger, the time to unwind also got bigger. So they increased proportionally in a sense. So the direct proportion. Okay. So as one increased, the other one increased. Estimate. Okay, now when we say the proportional, what I mean is as one increased, the other one increases. Not necessarily directly proportional. It could be by something else. Estimate the time taken for the string to unwind when the size of the piece of cardboard is 30 centimeters squared. Now 30 centimeters squared is between 24 and 48. So we need a time between 1.5 and 2.4. So what time could we write between 1.5 and 2.4? What must we do?
2.0.
2.0.
Yes.
So any time between 1.5 and 2.4 will do. Any time. Done. The larger the piece of cardboard, the more slowly it spins. Okay. Okay, so as the cardboard increased in size, the time taken for it to unwind also increased. So name the force that slows the spinning piece of cardboard down. Put your hand up if you know what the name of that force is. No, not gravity won't stop it spinning. Okay. Now God was not a force. Okay. Madam, Zainab. So what is the force that's slowing you down from spinning? What's it called? Okay, what do you call it?
Air resistance.
Air resistance.
That's a good one. Actually, no, that's
We can also write words like friction or drag as well.
friction.
Yeah, or drag. So any of those three particular ones will give you the mark. You will not get a mark if you write down gravity or just resistance. Okay, lovely. Okay, right. Whoever is singing, please can you stop, yeah? This is not the X factor. Okay, after the test, Owen thinks of 4 more questions about the spinning roll. Tick 3 boxes to show which of these questions he could answer by doing more tests with the spinning roll. Hang on a second. Will the time to unwind be longer if the string is longer? Could that be tested? Yes. Okay. What is the name of the force that makes the weight fall? No, not really. You can't test that one. That doesn't make any sense. How can I make the string unwind more slowly? You could investigate that. And what happens if I put 2 weights in the string here? We could definitely do that as well. So it's all those 3, not that one.
These two.
Okay. Question 3. This is question 3, part A.
Fish tag.
Okay. Philip's class. I never knew fish tanks were that exciting. It's caused you to spontaneously shout out. Philip's class has some goldfish in a fish tank. The picture below shows the fish tank. Write solid, liquid, or gas to complete each label on the diagram. So the lid is a solid. So inside the bubble we have.
Liquid.
Inside the bubble we have gas. No, not gas. That's gas.
Gas.
Okay, water is a.
Liquid.
Okay, now just to remind you folks, we are recording in the moment, so can you please keep the language civil and can you control ourselves, please? I know that's a difficult thing for me to ask you. And the gravel inside is a.
Solid.
I learned that from Minecraft.
Okay, excellent. Right. Philip needs to clean the fish tank. He takes the fish and the plants out of the fish tank. The teacher tips the dirty water and gravel from the fish tank into a sieve. This is a sieve. Complete the sentence below to show what happens to the gravel and the water when they are separated with the sieve. So let's start off with Zainab. Now, what happens to the gravel in respect to the sieve? How do they interact? So the gravel gets what?
Stays in the sieve.
How is that? So the gravel is too big, okay, to pass through and gets trapped. It's too big to pass through the sieve.
To the sieve.
To the sieve and gets trapped. Okay, trapped. So it stays. Now what about the water? The water easily passes through the gaps in the sieve. Easily passes through the gaps. Okay, gaps.
What is the first word? The water. Easily.
The water easily passes through the gaps in the sieve.
That don't look like an S.
Okay, that one's done. Well, I'll be happy with that. So the water can pass through the gaps in the sieve, whereas the gravel is too big, it gets trapped by the sieve. Okay, lovely. Beautiful. Let's just quickly pause it. Okay. There are microorganisms in the gravel. Write true or false next to each sentence about the microorganism living in the gravel. So the microorganisms are small enough to live between the gravel. Is that true or false? Okay, true. The microorganism can break down leftover fish food.
False.
True. That's what microorganisms are excellent at. They're breaking down food and stuff. The microorganisms living in the fish tank carry out life processes. Tick 2 boxes to show which 2 statements about the life processes of the living organisms are true. So the microorganisms need nutrients. Is that true?
No.
Yes.
Yes.
The microorganisms do not grow. That's false.
That's false.
The microorganisms do not reproduce. That's false because they do. So the microorganisms can move.
Obvious.
All living organisms can move. Lovely.
Everything living.
Okay.
Click 2 said not.
Right. Okay, right. Question number 4. Investigating pulse rate. Joe and Sabia are finding out about pulse rate and exercise. Their teacher tells them 2 ways they can measure pulse rate. Method 1, feel the pulse in your wrist and count the beats in a minute. Method 2, use an electronic sensor to measure the pulse rate. Joe says method 2 is better because it gives results more quickly. Give one reason. Other reason why method 2 is better at measuring pulse rate than method 1. So let's have a go at this question. Right. Okay, Zainab, can you give us a suggestion why we're going to use the second method? Why is it better? Because it is more. What's the word we're looking for?
It is more.
Shh, quiet.
It's more quicker.
Okay, more quicker. Okay,
More
we're using electronic sensor to measure the pulse rate, so
That's more
it is more
technical. Delicate.
accurate,
Accurate.
reliable. Yeah, it is less likely to make a mistake.
And
Okay.
you can get mistakes in your
And that's when you can yourself. So it is more.
reliable.
Okay, we can write an accurate and reliable. Okay, can you make sure you fit yours on the line? Because I'm writing quite big, so I'm using quite a lot of space. Can you try to fit yours on the line itself, please? It is more accurate, reliable. You only need to give one of those reasons, so that will do. I'll put that in there as an extra one just to give you a different choice when you write it down. Joe and Sabia plan an investigation. Their plan is shown below. So then record resting pulse rate, run for 2 minutes, record pulse rate again, rest for 10 minutes, repeat the test for skipping, dribbling, and so on and so on. Write the question Joe and Sabia could use their plan to investigate. So what they're going to mean? What kind of question could we do right here? Okay, Zainab, you put your hand up one.
You can say how
So it's questions about what? Questions about the different types of activities and connecting them to what? Pulse rate. So we need to make a question that connects pulse rate to
the activity.
the activity. So one.
You can do how many minutes did it take when you were skipping?
Okay, what about which exercise would make your pulse rate go up the most?
I
Yeah.
think
Okay, so which activity? Because she's doing it for a different activity. Which activity? I gotta write big, folks, but you have to write it and fit on. Which activity
Is
will make
can make.
your pulse rate increase the most? Will cause or make your pulse rate
higher.
increase.
Done.
Increase. Your exercises.
Okay, hang on a second. Right. So we said which activities, the question could be which activity will make your pulse rate increase the most? That could be the question. Okay. Joe exercises and Sabia records Joe's pulse rate. Why is it important that the same person does all the exercise during the investigation? This is a nice, lovely scientific answer that we say. So, well, okay, not you. Okay, Arwa. So the test is.
It's because their pulse is different.
Okay, so what's the purpose and to make the test?
Fair.
Fair, well done. So we have a fair test. So the test is fair. That's it, to make a fair test. So there's no cheating, there's no messing about. So the test is fair.
Can I read it? The table below.
Answer, where are you going to? Where are you?
The next page.
You're on the next page before I've even got there.
No.
No, she's on the next page. I'm on the next page. I should really start with the question.
On the next page.
Okay, question number 5. Page number 5. Is the next question now, yes? Okay, right.
No, that isn't the next page. That's not the next page. This
That's-
is the next page. The back. Turn back.
There's
Okay.
one before
The
that.
back one.
The start, there's one before that.
Science.
This one.
Yeah.
Hey.
Okay, the table below. Okay, the table below shows
There it is.
shows the results. Running, skipping, dribbling, jumping, before and after. What was Joe's pulse rate after skipping for 2 minutes? So after 2 minutes, what was it?
165. kicking.
1 minute 65.
Yeah, 1 minute.
1 minute 65.
No, 165, not 1 minute 65.
You can't get a minute of beating.
Okay. Which graph shows what will happen to Joe's pulse rate if she runs at the same speed for 15 minutes starting from rest? Tick one box. We need to think carefully about this one. Now remember, her pulse rate started low and it went up to a particular value. So will it be the first one?
Yes.
No, because it starts high, goes low. That's opposite. This one starts high, goes low. That's rubbish as well.
Low.
Okay.
No.
What about this one? Starts high, goes low. No.
What's this?
It has to be this one. It starts low and it goes to the maximum and stays at that maximum for a certain amount of time.
Yes, good, tick.
Tick. That one. These crosses which are put on there for illustration, don't put crosses on yours. Just put one tick, please. Okay, never mind if you have. Okay, the next question, question number 5, magnetic toy.
Okay, toys.
Sam has a toy made of magnets and balls. He tries to put different magnets together. There's a magnet, there's a ball. Write N or S on each, N for north, S for south, each of the magnets below to explain Sam's observation. Some have been done for you. So the ends of these magnets push away. If they push away, first of all, if that's north, then that one should be
South.
okay. That one should be south. Now because they're pushing away, that one has to also be south. And that one has to then automatically become north. The ends of these magnets pull together, so north, that one, opposite one has to be
South.
and that one has to be north and that one has to be
South.
Now let's explain it now. Now, why are these two south and Nayab? They're both south because like poles repel. Like poles means the same. These two are opposite because opposite poles attract. Opposite poles attract. That's the scientific explanation behind it. Okay, off we go. The magnet, go on, read it.
The magnets attract the balls. Sam makes a tower using the magnets and the balls. He wants to test how strong the tower is. He puts 100 grams mass on the tower. He adds masses until the tower falls apart onto the rubber mat. Mass is 100.
Okay, so Sam repeats his test with 2 different towers. His results are shown in the table below with 2 different towers. So tower 1, tower 2, looks like
3 towers.
okay, so there are 3 towers there. So mass held before tower falls apart. Okay, can we see the information there? There's nothing else in that paper now, is there? Question on the next part, yes?
Yeah.
Okay, let's go to the next page. So page number, here we go.
C.
It says tick 3 boxes to show which variable Sam kept the same to make his test fair. So what did he do first of all? He kept the
Size of each ball.
size of each ball, which is this one. Excellent. Excellent. What else? The size of each
Massive.
magnet.
Magnetic.
Magnet. Not the masses. The masses, they change them. Look at the picture over there. Look at the picture. So different masses. Okay, what about the size of the rubber mat? Has that got anything to do with it? No. What about the number of masses put on each tower? That's definitely changing. So that's not going to be kept the same. What about, hang on, what about the number of magnets in each tower? That's changing as well because we changed in the diagram. The number of,
That's the same.
so that changes. That's to stay the same. The number of balls in each tower. Lovely. Okay. So question part 3. Complete the graph by drawing the missing bar. Use the results table to help you. So now for 3 magnets, what did we have by the way? From your table?
A little one. So,
From the table that we had previously. Number 6.
do you need a ruler?
Here's number 4. Oh, here we go. So what was the word for 3? It was
700.
700.
So, do you need a ruler to get
Hang on 1 second.
You don't need a ruler.
Yes, you need to look at pass me. Okay, so what was it? 700 grams?
Yes.
Okay, right. I'm gonna try to draw a
Come on. Yeah. I'll take this and do it off. Isn't it? Oh, it's really
Okay, there you go. So it should be a 700. So 700 between 600 and 800 is 700. There you go. Should be that kind of height. Okay. It says here next, predict the mass that could be held by a tower with 4 magnets in each leg. Use the results table to help you. Now, what happens as we increase the number of magnets in each leg? What happens to the amount of mass that it holds? Does it increase or decrease? It decreases. So if you add more magnets, magnets here, it's going to decrease it from 700 down to what?
500.
About 500?
Yeah.
Okay, so anything between 200 and 600 will be the right answer. So I'm going to write down here 500 will do as an answer. But you're allowed an answer between 200 and 600. I'll put that in brackets. So any answer between that will give you the correct answer. Any answer between those two numbers. Yeah. So you have to realize it's going to be less than 700, but more than 200. So around about 600, 500, 400, and 300. Done. Okay. Separating materials. Vishal has a mixture of salt and sand. He adds some water and stirs the mixture. Complete the sentence below to show what will happen to the salt and sand mixture after Vishal stirs in water. The salt will, hang on 1 second. Let's give somebody else a chance. Hang on. Shh. Go on.
The salt will dissolve.
Excellent. The salt will dissolve, okay, and the sand will
Stay there.
stay as it is, do nothing, sink to the bottom.
And it will be really like.
Okay, the salt will dissolve.
I learned remain untouched or
Okay. What about the sand? The sand will not dissolve.
It will stay.
I just wrote it remain.
Yeah, will not dissolve and remain at the bottom of the jar.
Not to dissolve.
Remain at the bottom jar. Done. Vishal uses this equipment to separate the sand from the salt and water. Filter paper, funnel, and then we have a little beak at the bottom. Describe how the sand is separated from the salt and the water with this equipment. The salt, the water. Okay, what happens to the water? The water, it easily goes through the water easily passes through the filter paper. Are you writing this down? Or are you just finding yourself the ruler? Easily passes. Can you fit yours on the line, please? Through the passes through the filter paper. Okay, the water easily passes through the filter paper. What about the salt? The salt also passes through the filter paper with the water. Yes?
Yeah.
Salt easily passes through with the water. Passes through with the water.
So easily pass.
Hang on a second. Sand gets trapped in this filter paper and cannot pass through.
Gets trapped.
Trapped.
I'm just gonna write gets trapped. Gets trapped for the best time. You're trapped.
Shh.
Okay.
Okay, there's our 3 answers. Done. Have we got that down, ladies?
Yeah.
Got that down? What I've written there? Yeah? All of it?
No.
Yeah?
Yeah.
Easily passes through the filter paper. The salt easily passes through with the water. The sand gets trapped in the filter paper. Yeah, hold that down.
To get trapped.
Come on. Qasim, you got that?
Yeah.
Are you happy with that?
Yeah.
Mr. Kamal? Are you happy with what he's doing, yeah? Yes.
That's it.
With this water through the filter paper. It gets trapped in the filter paper. Okay, are we ready for the next page?
Yeah. Take one box.
Okay, question number 7. 6C, sorry.
6C.
Okay. Tick one box to show which process Vishal could use to get the salt back from the salt and water mixture. Put your hand up if you know this.
No.
So now the salty water's passed through, it's in the bottom of the beaker. You want to separate the salt from the water. What would we do? Which one of those would we use? Now you wouldn't use filtration, you just use filtration, and you wouldn't use sieving. Them two are nonsense answers. So either condensation or evaporation. Go on, let's have Qasim. Well done, excellent answer. Evaporation is the correct answer. Okay, magnets can be used to separate some mixtures. Tick one box to show the mixture which could be separated with a magnet. So now brass pins and peas. Well, brass is not magnetic, so I'm just going to put a little cross there, that's rubbish. Okay, steel, paper clips and rice.
No.
Rice.
No.
Rice.
Hang on a second.
Opposite.
Okay, hang on a second. Iron nails, iron nails and steel paper clips. Could you separate those two? The answer is no, because they both get attracted to magnets. Copper, beads and brass pins, they're both are non-magnetic. Won't work. So which one's left? Steel paper clips are magnetic and rice isn't magnetic. So yes, you could do that one. Take. Next. It says that explain how a magnet can be used to separate the two objects in the mixture you chose. So D part 2. So what will, so we can say here the steel paper clips, the steel paper clips, steel paper clips will be attracted to the magnet. Will be attracted to the magnet. They attract the magnet, and the rice won't.
And the biryanis. Biryani.
Okay, done? Okay, right. We got like one page left and then you're finished. Okay, then we have a break.
One page.
Okay.
No, 3 pages missed on. One page.
One page and one side.
One page.
Two.
Question number 7, trees. Class 6 are investigating trees in their school grounds. Describe one function of the roots. Okay, put your hand up if you know the answer to that. What is one function of the roots? There's quite a few functions. I want a couple of people to give me one each. Okay, Arwa, what do you think the roots do for a tree?
They collect the fruit.
Okay, they help it to absorb minerals and water. What else? Go on.
It makes the
It.
grow.
Okay, no, not makes it grow, but absorbs the minerals, so it helps in the growing process. But go on.
It keeps it down.
So what do you call that? It anchors.
It
Anchors the tree into the ground, holds it down firmly. What else? Qasim?
That's all I was going to say.
Okay, let's write that down. So we can write down here.
The tree.
So the roots anchor the tree in the ground.
Somebody.
Okay, don't worry about that. So the roots anchor. Okay, Zara, we're writing this down. Anchor the tree into the ground. Tree. So they hold the tree down, stop it from blowing away. Okay, what's another answer we could write down? The roots absorb moisture and minerals from the soil. Yes? That could be another answer. The roots absorb water and minerals from the soil is the second possible answer. So I've given you that one verbally. Okay, question part B.
The tree
Qasim,
leaves.
tree leaves absorb light from the sun. Karen reading.
Take
Zainab.
one box to show the light progress for which
Process.
leaves absorb the light.
Okay, now when the leaves absorb light, what are they doing? Which one of those four things are they doing? Are they helping us? Not put your hand down, somebody else. Is it reproduction, movement, nutrition, or
Nutrients.
well done? Nutrition. They are making food for the plant. Nutrition is correct. Done. The children observe the flowers on some of the trees. Complete the labels to name the parts of flower A on the diagram below. Now, actually, I don't think you can see. You see in yours?
Yes.
No.
Okay, I think there's some printing error there. Misprint. So I'll have to tell you what that is actually. Okay, now the first one was actually pointing to the stigma. So we'll have to just write it in. You have to take my word for it. He was pointing to the stigma.
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 That's the part that's inside the flower. That's the petal, and the part on that was pointing to the part on the bottom of the flower, which is called the sepal.
Sapul.
No, not sepal, sepal.
Stigma.
Okay, that's done. Okay, done. Last page.
Not the last page. Second last.
This is the
Who's the last page by another slide left?
yeah. What's the last one? Last double page. Okay. Shh. Alright, let's focus, folks. Come on. Okay. Here are the children's observations on flower B. The flower does not have a smell. It does not have bright petals. It has lots of long stamens. Tick one box to show how flower B is pollinated. If it's a long stamen, it'll be pollinated by the
Stem.
by what?
The wind.
By the wind. Why is that? Because it's not attracting any insects. It hasn't got a smell. It's not bright colored. Smell, plants with smell or bright colors, okay, that's attracted by little insects and attract to also those one.
What is pollinated?
Pollination is when they, when they get the pollen, and it has to go this part of the reproduction cycle. Okay, pollination.
When the wind helps them to fly.
The wind helps the pollen to move from one part of the plant to another part of the plant. The table below can be used to sort the flowers on the trees. Write all the names of the flowers in the correct. Arma, can we focus please? Correct boxes on the sorting diagram. One has been done for you. Hang on one second. Okay, I think we have lost the pictures again. Okay, so it's going to be difficult for us to do that particular question. So what we can do here, I can tell you where the answers should have gone if you could see the pictures. So the pear and alder go here.
Where?
Elder.
Okay, almond will go here.
Look at the top.
Lilac will go here. You can't see the plants that are missing. I'm just telling you where the answers would have gone if you could see them.
What's the one in for elder?
Magnolia goes there.
No.
Magnolia sounds like paint that you buy.
What's that? No.
Huh?
Oh,
That one, almond. Badam.
Lila.
almond.
I like badam. What's that
Leaf.
Especially salty badam.
What
about Mana Ash?
Who's using? Mana Ash is already written.
Mana
It's
Ash.
like a new
What's
leaf.
Mana
This is chocolate.
Mana Ash.
Okay. Right. You calm down, please. So excited by reading it. Okay, question number 8. Lucy has a fruit and nut chocolate bar. Take 3 boxes to show 3 properties of solid chocolate. So solid chocolate is, how would you describe solid chocolate?
Does not flow.
Does not flow. Excellent.
It's not. It's just everything down.
Does not change shape.
It's everything down there.
Thank you. Does not change volume. These are all the properties of a solid chocolate. Flows will be liquid, change shape, liquid and gas, change volume, gas. Okay, so it's definitely these three here. Lucy wants to separate the fruit and nuts from the chocolate. If I heat the chocolate bar, the chocolate will change from a solid to liquid. Name the scientific process that happens when Lucy heats the chocolate bar. Put your hand up, Qasim. Melts.
Melts.
Yep.
Okay, so it melts. Okay, next. Lucy uses a sieve to separate the liquid chocolate from the fruit and nut. Describe one property of the liquid chocolate that allows it to go through the sieve. Give me a property of it.
I don't know.
So what can you say? So the
Um,
melted chocolate behaves like a liquid, and liquids can easily pass through gaps. So the melted chocolate,
it's because gas is not like strong.
the melted chocolate,
It's just like
chocolate is a liquid. Is a liquid,
And the solid.
liquid, and liquids can flow.
Liquids can flow.
And liquids
Liquids
can flow.
It can flow.
Liquids can flow.
Okay, that's the end of that test paper.